Hello everyone! In today's video about troubleshooting OSPF neighbor adjacencies, I would like to review how to troubleshoot issues related to mismatched area types, different subnets, passive interface, and mismatched authentication information. But before we continue, I would like to ask you to subscribe to my channel with notification bell on and show your support by hitting like button. So let's get started. Mismatched area types. By default, the OSPF area is classified as a normal area, but you can change it. You can change OSPF area type to a stub area or not so stubby area to control the link state advertisements which will be sent into the area by a area border router. Routers in the same area must agree on the type of the area to form adjacencies. Belonging of the neighbor router to the area is identified in a stub flag in the header of the OSPF hello packet. To verify types of the networks connected to the router, use the following commands: show IP protocols. In this example, you can see in the output that we have two areas on this router, and those areas are normal. This is not that much informative, and to find out which area is which type, you can use command show IP OSPF, and then in the output you will see that, for example, area 1 is a stub area. Also, debug command can be used when troubleshooting adjacencies to find issue with mismatched area types. We can use command debug IP OSPF hello, and then in the output, if we have mismatched area types, you will see kind of this syslog message saying that mismatched stub transit area option bit. Okay, let's review example for issue with mismatched area types. We have network with area 0, area 1, and area 1. Show IP OSPF neighbors. As you can see, we don't have neighbor relationship formed with router R4. Show IP protocols. We can see that we have two areas on these routers, and those two areas are normal type. Show IP OSPF. We will not see anything useful in the output for this router because we have area normal type. Let's go to router R4. Show IP OSPF neighbors. Okay, we have two neighbors, but stay down. Show IP protocols. And you can see we have only one area on this router, and this area is NSSA. Show IP OSPF. And here we will see area 1. It is an NSSA area. Show run section router OSPF 100. And as you can see, this area 1 is configured as NSSA for this router. Conf t. Let's fix it. Router. Oh no, let's check also debug command. Debug IP OSPF hello. Okay. As you can see, hello from router 3 with mismatched NSSA option bit, and hello from router R1 with mismatched NSSA option bit. Let's fix it. Conf t router OSPF 100 no area 1 NSSA. Now we should see set and show IP OSPF neighbors. And we can see now we have everything in state full. Let's check also router R1. Show IP OSPF neighbors, and now everything is good. We have two routers. Different subnets. So for two routers to form neighbor adjacencies for OSPF, they need to have the same subnet mask on the interfaces, on the link between them. For example, here on this interface and on this interface on router R1, they need to have the same subnet. There are many ways to check the subnet on the interfaces, but the easiest way to check is using these commands. Show running config interface with interface name and interface ID. In the output you will see the configured IP address with network mask. And the second command, show interfaces with interface name and interface ID. You will see also the IP address of the interface with network mask configured in the interface. Okay, let's review example related to different subnets. Related to this issue, we have network with area 0, area 1, area 1, area 1. Router R1, show IP, OSPF, neighbors. As you can see, we don't have neighbor relationship formed with router R2. Show IP interface G00. Let's check network, subnets, 1201 to mask 24. Show interfaces G00. Same here. And let's go to router R2. Show IP interface G00. And we have subnet N1202, mask 22. So we have incorrect subnet. Show interface G00. Yes, G02, mask 22. Show run interface G00. As you can see, we have mask 255.252. We need to change it. Let's fix it. Conf t interface G00 IP address 10.4.12.02.255.255.255.0. And let's wait. Okay, now we see that process 100 neighbor for on the interface G00 from loading to full. So then we have full state of neighbor relationship. So IP OSPF neighbors. Now you can see everything is good now. Let's just double check on router R1. Show IP OSPF neighbors. And we have both neighbors with formed relationships. Issues related to passive interface. Passive interface does two important tasks. First one, it reduces OSPF related traffic on the network. And the second one, it improves OSPF security. When an OSPF enabled interface is configured as passive, it doesn't send and receive OSPF packets, but still the network ID of the interface is being injected into the OSPF process and is being advertised to other OSPF neighbors. From a security point of view, when a rough router is attached to the network on that interface, it will not be able to form neighbor adjacency with a legitimate router on that interface. The problem shows up when the wrong interface is configured as passive. Then legitimate neighbor relationships are not formed. To check which is the interface is configured as passive, you can use command show IP protocols, and in the output of the command you will see passive interface, and then you will see your interfaces configured as passive. If you don't need this interface configured as passive, and this is the issue of routers not form neighbor adjacency, you need to change your configuration. Okay, let's review possible issue with passive interface. We have network with area 0, area 1, area 1, area 1. Let's go and check. Show IP OSPF neighbors. You can see we don't have neighbor relationships with R2. Show IP protocols. We don't have passive interfaces configured here. Let's do debug. Debug IP OSPF hello. Let's wait what we receive. Okay, we send hello to area 1, received hello from area 1, and we send hello to area 0, but we haven't got any hello from area 0. Probably issue with R2. Let's go to R2, show IP protocols, and you can see that G00 interface is passive. The interface facing router R1. Show run section router OSPF 100. Yes, so we can, let's fix it. We just remove this configuration conf t. So this is issue related when you by mistake placed incorrect interface into passive. It's not gonna send any hello packets. Passive interface and router OSPF 100, no passive interface G00. And as you can see already, we have neighbor relationship with router R1. Show IP OSPF neighbors. Boom, and we have neighbor R1. Show IP OSPF neighbors. Now everything is good. The next issue about OSPF failing to form neighbor adjacency is related to mismatched authentication information. Authentication helps to assure that OSPF-enabled routers form neighbor adjacency only with legitimate routers, and to assure that they accept OSPF packets only from legitimate routers. When authentication is implemented on the OSPF-enabled routers, two neighboring routers must agree on the authentication type and settings for a neighbor relationship to form. The most useful method to use while troubleshooting OSPF authentication is spot the difference. OSPF supports the following three types of authentication. First one is null. This is the type 0 authentication, means that there is no authentication at all. Plain text. This is type 1 authentication, and it means that routers send in credentials in plain text. And MD5. This is type 2 authentication, and routers sends hashes of the passwords. OSPF authentication can be enabled either on interface by interface basis or globally to all interfaces at the area at the same time. To verify if authentication is enabled for the entire OSPF area on the router, you can use the following command: show IP OSPF. And in the output, you will see area has message digest authentication if authentication enabled for entire OSPF area. But if you have authentication enabled on the interface by interface basis, you will not see this message in the output of this command. Then you need to also check interface. Show IP OSPF interface with interface type and interface number. And in the output, you will see, for example, cryptographic authentication enabled or message digest authentication enabled, and the information about which key ID is used. And then you need to verify if your key is correct on the interface. Then you need to use show running config interface with interface type and interface number command. And in the output, you need to check the key for authentication. And the last useful command to check mismatched authentication information is debug IP OSPF adjacency. If you have some mismatched authentication information, you will see this output: mismatched authentication key and key ID. Okay, let's review example for mismatched authentication information. We have network with area 0 here and area 1, area 1, area 1. I have OSPF authentication configured for entire area on router R1 and on interface basis for R2. Let's see what we have on router R1. Show run section router OSPF 100. And you can see area 0 authentication message digest, show run interface G00, and our IP OSPF MD5 key Cisco. So IP OSPF. Here we will see in this command show IP OSPF that area has message digest authentication. Show IP OSPF interface G00, and you can see that here we can see also cryptographic authentication enabled. Youngest key is 1. And let's go to router R2. Show IP OSPF. As you can see, area has no authentication. But if I go show run interface G0, show IP OSPF interface G00, I will see cryptographic authentication enabled. Youngest key ID is 1. Show run interface G00, and you can see that here it is enabled on the interface by interface basis. Show IP OSPF neighbors. We don't have router R2 in our neighbors, so we have some issue. Let's assume that as we're talking about authentication information, that issue related to authentication information. Let's use debug IP OSPF adjacency. And let's see what we're gonna see on this in the output. As you can see in the output, we received packet with mismatched authentication key ID. Let's see, show run interface G00. We have key Cisco, and on R2 show run interface G00. We have key Cisco 1, so we need to fix it. Const interface G00 IP OSPF message digest MD5 and key Cisco. Now we should see formed neighbor adjacency. Yes, with neighbor 11 from loading to full. Show IP OSPF neighbors. And you can see now we have our router R1 for R2 as neighbor. They formed OSPF neighbor adjacency successfully. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos, but for now just goodbye and see you soon.